Welcome back, automotive enthusiasts and EV fans, to another exciting deep dive into the rapidly evolving world of electric mobility. Today, we have a massive story coming straight out of Ingolstadt that proves the future of electric vehicles is not just about cramming the largest, heaviest batteries possible into a chassis, but rather about mastering the delicate art of absolute engineering efficiency. Audi has officially dropped the curtain on the technical details of their highly anticipated upcoming compact electric model, and it is a true mechanical marvel. We are talking about the all-new Audi A2 e-tron, a vehicle that proudly carries the monumental title of being the most efficient Audi car of all time. If you know your automotive history, the A2 nameplate holds a very special place in the hearts of efficiency nerds. Back in the late 1990s and early 2000s, the original A2 became a legend with its aluminum space frame and its groundbreaking 3-liter version, making incredible fuel economy its hallmark. Now, the CEO of Audi AG has stated that this exact vision is being carried forward with the new Audi A2 e-tron. It is a masterclass in outstanding efficiency, excellent everyday usability, and a crystal-clear understanding of what modern customers truly expect from the next generation of electric mobility. Let us break down exactly how Audi achieved this incredible feat without relying on simply enlarging the battery pack. At the heart of the headlines is the jaw-dropping preliminary energy consumption figure. The A2 e-tron, specifically the 140 kilowatt power level model equipped with the optional Efficiency Package 1, achieves a staggering 12.8 kilowatt hours per 100 kilometers based on the rigorous WLTP testing cycle. To put that into perspective, this car sips electricity so delicately that it outpaces nearly everything in its class. How did they achieve this? Audi attacked the efficiency problem from 3 distinct angles: sophisticated aerodynamics, highly advanced drive technology, and a battery architecture deeply optimized for everyday use. Let's start with the aerodynamics because, as we all know, pushing a vehicle through the air at highway speeds requires a tremendous amount of energy. In fact, at speeds of around 100 kilometers per hour and above, aerodynamic drag accounts for more than 50% of a vehicle's total energy demand. Every tiny reduction in drag brings a direct, noticeable improvement to your consumption and your range. The A2 e-tron boasts an incredibly slick drag coefficient of 0.24, which is officially the best in Audi's entire compact lineup. The engineers didn't just rely on a rounded front end and a flowing aerodynamic roofline, they dug deep into the microscopic aerodynamic details. The front flanks of the vehicle feature strategically placed air curtains, which are specialized channels that expertly redirect airflow to suppress turbulent air around the sides. They also incorporated gap reducers and gap breathers to calm the chaotic air that naturally forms around the wheel arches. But one of the coolest aerodynamic features built into this compact powerhouse is the active cool air intake. During normal driving conditions and at higher cruising speeds, the intake shutters remain completely closed, slicing through the wind and drastically reducing drag to optimize your driving range. However, when the vehicle demands extra cooling, like during rapid fast charging sessions, aggressive acceleration, or navigating through intense summer heat, the active shutters intelligently open up to protect the battery and the power electronics. Taken together, these painstaking aerodynamic measures alone reduce the WLTP energy consumption by up to 0.9 kilowatt hours per 100 kilometers, compared to an identical vehicle without these specific modifications. That's essentially free driving range gained purely by outsmarting the wind. Moving underneath the beautiful exterior, the upgraded electric drive system is another area where Audi engineers worked their absolute magic, making it up to 10% more efficient than previous iterations. The electric motor driving the A2 e-tron is a permanently excited synchronous motor that has been engineered specifically to maximize efficiency and driving comfort in everyday traffic scenarios where customers actually spend most of their time. The magic happens thanks to 3 key advancements in the powertrain architecture. First, the power electronics have been completely revolutionized. Audi replaced traditional silicon technology with cutting-edge silicon carbide semiconductors. This significant upgrade drastically reduces electrical switching losses, especially when the car is operating under partial load. Furthermore, a variable switching frequency cuts losses by up to 20 watts, and alternative modulation techniques reduce these losses by up to 33% when compared to conventional manufacturing methods. Second, the physical electric motor itself has been refined. By using thinner laminations measuring just 0.2 millimeters instead of the standard 0.3 millimeters, Audi significantly reduced what engineers call iron losses. They also switched the stator winding from a star configuration to a delta configuration, which brilliantly shifts the motor's operation into a much more efficient speed range. Finally, the transmission benefits from a brand new low-friction oil that noticeably reduces internal friction losses. The engineers gave it a taller gear ratio of 10.2 to 1, which actively lowers the motor speed at higher road speeds, further reducing energy consumption during long highway cruises. Powering all this ultra-efficient hardware is a 61 kilowatt-hour lithium iron phosphate, or LFP, battery. Audi chose a highly advanced cell-to-pack design, meaning the individual battery cells are bonded directly into the main housing. This layout eliminates bulky battery modules, dramatically increasing the packing density and allowing the high-voltage system to store more energy in a significantly smaller physical footprint. But the choice of LFP chemistry is the real star of the show here. Unlike other battery types, the LFP battery does not require any rare earth elements, making it vastly more sustainable. It also ages significantly slower and is widely considered to be one of the safest battery chemistries on the market today. Because of this inherent chemical durability, Audi proudly states that owners can routinely charge the A2 e-tron to a full 100% in their everyday use without worrying about rapidly degrading the battery's long-term health or performance. However, Audi knows that hardware is only half the battle. The electronic brain of the vehicle is just as crucial. The automaker stresses that the greatest efficiency gains actually emerge from the precise, deeply integrated interplay between the battery, the thermal management system, the charging electronics, and the software algorithm. For example, Audi developed an adapted cooling strategy that pushes the wall-box charging efficiency to an impressive 92.6%, meaning less energy is wasted as heat and more goes straight into the car for consistent daily charging. The intelligent software algorithm accurately assesses the battery's state of charge and state of health in real time, perfectly optimizing every drop of electricity. And if all of that wasn't enough, the A2 e-tron is also fully equipped for the future of decentralized energy management with bi-directional charging capabilities. With an Audi-recommended charging box, the vehicle-to-load feature allows you to power external devices directly from the car's massive battery. And the vehicle-to-home functionality allows the A2 e-tron to act as a home energy storage system, seamlessly integrating into your smart home grid to power your daily life. The upcoming Audi A2 e-tron is more than just a new electric hatchback. It's a masterclass in holistic engineering. By meticulously eliminating wasted energy from the aerodynamics, the powertrain, and the software control systems, Audi has created a brilliant modern successor to the legendary 3-liter car and set a brand new benchmark for the entire compact EV segment. Thank you for joining us today for this comprehensive automotive deep dive. Remember to drive safe, and we'll see you in the next video.